Well, hey guys, this is the last video for our topic. We have one more method on how to solve quadratic equations, and this is the method that I say the best for last. It's the method that's going to be your backup plan, and you can use it regardless of what kind of equation setup you have to solve any quadratic equations, provided that you're not restricted on a particular method. So without further ado, I'm going to show you how we get to this because we're going to solve the general equation that you see on the bottom of my screen here on page 14. And then the result will be the method we use to solve other quadratic equations. So I'm going to go through this real fast. You don't have to know these steps. I'm just showing you the algebra we use to solve this general equation. It also involves some things that you don't have knowledge of yet, okay? So if you notice the steps here, step 1, pretty straightforward. Step 2, pretty straightforward, okay? We're trying to isolate x squared, okay? So steps 1 through 3, that's what we've done. We've isolated x squared. Step 4 is where it gets a little interesting. Now in step 4, we're doing a process called completing the square. So what I'm doing is I'm making the left side expression a perfect square. So I'm adding a term to each side of the equation. So the left side becomes a perfect square, which is what I do on 5. So I rewrite it as that square. And on step 6, okay, I find common denominators of the terms on the right so I can combine those together. Then on step 7, I do the square root method that I learned from the previous video, the previous lesson. Okay, simplify it in step 8 and continue to simplify it a little bit more in step number 9. Okay, and so I'm ready to do step number 10 and finish this. I'm now on the last step. I'm just going to get x by itself. Okay, so how do you finish solving this equation for x? Well, if I want to get x by itself, I have to subtract b over 2a from each side. Okay, so on step 10, when I do that, I will have x equals the opposite of b over 2a plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, and if I mash those two fractions together because they have the same denominator, I get this final result. I will get x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. And that is what we call the quadratic formula. Okay? This is a very important result. So what we did was we took the general form of a quadratic equation and we solved it in general terms. So here's the fun little fact about this. If I know the values of a, b, and c, all I have to do is plug those values where they are in the formula and then simplify it to get my final roots. One will be the plus from the plus or minus, and one will be the minus from the plus or minus, okay? So all I have to do is simplify this expression when I plug in my 3 coefficients, and I will get my solutions to my equation, all right? And that's why this method works for any setup, because we can get the setup accordingly. We can get A, B, and C, plug them into the formula, and then we're good to go, all right? This formula is so important. It's so important that you should probably memorize this formula right here, okay? It's a very important formula. You're going to be using it extensively in Algebra 2, maybe even some in geometry. So you're going to want to know this formula. It's a good one to put in your memory banks because I don't usually tell you to memorize things. This one you need to memorize. This one you need to know for the long term. It's going to be very, very important if you do. It'll save you a lot of time. All right, everybody. So I jumped ahead to the next example. Before I show you the method written out, we're going to do an example together so you get an idea of how the numbers plug in and you get an idea of what we need to do here before we actually show you the method. So notice that in my equation, these are going to be easy numbers to work with. This is actually factorable, so it's going to be easy numbers to work with. And we'll work with more complex numbers later on in some other examples. Okay, so we're going to start out, we're just going to figure out what the values of a, b, and c are, and those are the coefficients for the squared term, linear term, and the constant term. So notice that one side of the equation is equal to 0, which is what we need to have happen again, just like in the factoring method I showed you in the first video. So that's going to be important as well. And we'll sum all this up in the method in just a few minutes. So start out here. A is the number in front of x squared, that is positive 1. B is the number in front of x, that is negative 6. C is the constant term, that is 5. All right? So I'm going to put these numbers into the formula, and then I'm going to solve the formula for x, okay? Just by simplifying this expression here on the left side. The opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2a, okay? So when I simplify that expression, I will have my 2 roots, all right? Now, it's very important that we think of this as the opposite of b. This negative b here, you think that is the opposite of b. So this expression right here, okay, is not negative b, because if b is negative, like it is in our example here, I don't write negative 6. I write the opposite of 6, okay? Or the opposite of negative 6, my mistake, which is positive 6. So again, you want the opposite of your b value there, okay? So here I go. X equals the opposite of b, which is 6. Plus or minus the square root, make it long. Okay, you got a lot of things right underneath that radical symbol. Okay, the square root of negative 6 squared, b squared, minus 4 times 1 times 5. Okay, and we're going to write that all over 2a, which is 1. So I have, again, just to recap, opposite of b is just 6, plus or minus b squared, negative 6 squared, minus 4. A is 1, c is 5, so 4 times a times c, over 2 times 1. Now I do is use the order of operations and simplify it. Okay? That's all I have to do. So, here we go. X equals 6 plus or minus the square root. We're going to do negative 6 squared, that's 36. Now over here, okay, I like to treat this as a negative 4 every single time, okay? That way, I don't have to worry about if that product is positive or negative. I just multiply a and c by negative 4 every time, and whatever that becomes, that's it, and I don't have to worry about it anymore, okay? So a little trick there. So we're going to do 36, and we're going to do negative 4 times 1, which is negative 4, and negative 4 times 5, which is negative 20. So we're going to have 36 minus 20 all over 2. Okay? Next step, we're going to simplify the radical. So I have x equals 6 plus or minus the square root of 16 over 2. Okay? And then we're going to do the square root of 16, which is 4. So we're going to have x equals 6 plus or minus 4 over 2. Now this looks like some solutions you could have had from the previous topic. So we're just going to break it down. We'll do 6 plus 4 over 2 and 6 minus 4 over 2. And those are going to be the two solutions. So we're going to do x equals 6 plus 4 over 2. Which is 10 over 2, which is 5. So there's solution 1. And then solution 2 is going to be x equals 6 minus 4 over 2, which is 2 over 2, which equals 1. So the two solutions, or the two roots of this equation, are 5 and 1. Okay? Yes, factoring might have been easier to solve this one, but not every expression factors also. So you might spend some time factoring or trying to factor an expression that doesn't factor. So whenever you're in doubt and you need to solve a quadratic equation, use the quadratic formula unless you're restricted and you've been told in directions to do it a different way. Okay, this is your backup plan, regardless of what kind of equation is thrown your way. Okay, so you can always use the quadratic formula to solve any quadratic equation. All right, here are the steps. So as we talked about, I'm going to put them all on the same page so we can see them all. Okay, there we go. You need to rewrite the equation in standard form where one side is 0, just like it was at the beginning. Okay, we've got to find the values of a, b, and c. So let me highlight these as we go through them. So step 1, make sure one side is 0, other side is standard form. Okay, step 2, find the values of a, b, and c. Step 3, okay, use the quadratic formula. Simplify it using order operations, okay, to solve the equation and get your roots, okay? And then, if necessary, on step 4, you might have to do some cancellation of some common factors and simplify some radical expressions, okay? And we're going to do an example that will encompass that later on here in this video, okay? So that is how you solve an equation using the quadratic formula. So I'm going to go through a couple of additional examples here for you. I'm going to do example 1 with you. I'm going to save example 2 for you to try on your own. Okay? And see what you can do with it. And then we will look at some more complex ones that involve some radical expressions. Okay? So let's go ahead and look at the first one right here. Okay, so here we go. Now, the first thing you need to notice is that one side is not equal to 0. So we're going to make that happen. And again, remember my little rule of keeping x squared positive, and it's positive already here on the left side, so we want to make sure that stays positive. So all we're going to do is subtract 72 from each side. Okay, so I get x squared minus x minus 72 equals 0. Okay, and now I'm going to find the values of a, b, and c. So a, b, and c. Okay, I'll stop for a second. I want you to try to figure out what a, b, and c are, and then you can unpause and we'll go over it together. So pause for a second, figure out what a, b, and c are. Okay, so what you should have figured out was that a is 1, b is -1, and c is -72. All right, those numbers get plugged into the formula. So I'm going to write the formula down again for our reference. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, and then down here underneath my new equation, okay, right here, we're going to plug in the numbers, all right? So x equals the opposite of b. b is -1, so I get the opposite, that's 1, positive 1, plus or minus the square root of -1 squared minus 4 times 1 times -72. Go ahead and extend your radical sign if you need to, all over 2 times 1. A will not always be 1. It just happens to be 1 for the first 2 examples that we've done. Okay, so that's going to come into play later on. Okay. Now what we have to do is just start simplifying it. So we have x equals 1 plus or minus square root of 1. Okay, that's -1 squared. And then we need to do -4 times 1, which is -4. And then -4 times -72. We'll do a little scratch work over here for that one. So 72 times 4, I know the answer is going to be positive, so I get 288. So -1, I'm sorry, plus 288 over 2. Okay? So then I have x equals, add those up in the radical, 1 plus or minus the square root of 289 over 2. Okay? Luckily for us, square root of 289 is 17. So x equals 1 plus or minus 17 over 2. Okay? And then over here to the side, I'm going to do the answers. So to find the roots. So we're going to do x equals 1 plus 17 over 2, which is 18 over 2, which is 9. And we also have x equals 1 minus 17 over 2, which is negative 16 over 2, which is negative 8. Okay? And if we want to check these, we can do that. Okay? We have a little room down here. We'll do a quick check on one of these. Let's check negative 8. Okay? So we will do, remember the original equation is x squared minus x equals 72. So we're going to check and see. Is negative 8 squared minus negative 8 equal to 72? Okay. Well, that's negative 8 squared 64. Double negative becomes a positive, so 64 plus 8 does equal 72, so it checks. So these are the final answers right here. Okay, and that's the first example. So I'm going to give you a couple of tips on the second one. I'm not going to solve this one for you. I want you to try this one on your own. Okay, and then I'll discuss the answer with you for a minute because the answer does have a unique result we need to discuss. Okay, so first of all, try solving it yourself, making sure you get one side equal to 0, finding your A, B, and your C, and plugging those numbers into the formula correctly. I'll pause for a minute and give you a chance to try it yourself, and then you can catch up with me, and we'll talk about the final answer. Okay, so if you solved it correctly, or if you set it up correctly, you should have gotten 4x squared minus 4x plus 1 equals 0. Okay? And A would have been 4, B would have been negative 4, and C would have been 1 with this one. Okay? That's great. If you plugged everything in the formula correctly, you should have gotten x equals 4 plus or minus the square root of negative 4 squared minus 4 times 1 all over 2 times 4, because A was 4 this time. Okay? Now, the really cool thing that happens here, let me change this so it doesn't look like a 1, so it's like a 4. There we go. Okay? The really cool thing that happens here is that you might have gotten x equals 4 plus or minus the square root of 0 over 8. Okay? That's correct. The square root of 0 is 0. So we have x equals 4 plus or minus 0 over 8. Well, 4 plus 0 is 4, and 4 minus 0 is 4. So the final answer here is x equals 4 over 8, or 1/2. Okay? When this radical becomes 0 right there, then our answer is a double root. Okay? So it's the same root repeated. And so there was only one solution to this one, one unique solution to this one, but it's repeated. So there's 2 times where we have 1/2 as a answer. Okay? That is the second example. Let's take a look at the next couple of examples. So we're going to work these out together, and then we'll do the story problem together, and we'll be finished with this lesson in this topic. So here's the next problem, example 3. Okay, so we already set equal to 0, which is great. So we're just going to go ahead and find our A, and our B, and our C. So I'll let you do that while I set this up, and I'll pause for a minute. Okay, so A equals 1, B equals 7, and C equals negative 3. Now I'm going to pause again and let you solve the problem using the quadratic formula, and then I'll catch up with you after you plug your numbers in and you've gotten what you think are your final answers. So I'm going to pause again. Okay, so when you put this in the formula, you should have received the following result. X equals the opposite of B, which is negative 7, plus or minus the square root of 7 squared minus 4 times 1 times negative 3 all over 2 times 1. Okay? And I'm going to go ahead and finish this one out here for you real quick. Negative 7 plus or minus square root. This is 49. And negative 4 times 1 is negative 4. Negative 4 times negative 3 is, whoops, I lost my 49. So 49 plus 12 over 2. Add 49 and 12 together, you get 61. Okay? Now, 61 is not a perfect square factor or perfect square number, okay? Nor does it have any perfect square factors. It's prime. So, we are finished with this problem. That's as far as we can go. We can approximate the radical, and when we do a word problem, we are going to approximate radicals that aren't perfect squares. We are going to simplify those so we can get decimal answers or approximations for our values, our roots. But since this is not a word problem, we're going to leave this in exact form as long as everything is reduced. Okay? So we are finished with problem number 3. This one is done. Let me draw that box again. Try one more time. There we go. All right. Last example before the word problem. Number 4. Again, I'm going to pause and let you try to work on it your own, and then we'll catch up at the end, and I'll get going here in a minute or so, and we'll work on how to get the answer finalized, make sure it's in reduced form. So pause for a minute, get your chance to solve it yourself, and then we'll catch up here in a couple of minutes. Okay, so if you do it correctly, again, it's already set equal to 0. That's not the point here. The point is the answer is going to be a little bit weird. So we need to make sure we get that simplified as much as we can. So A is 1, B is negative 6, C is positive 3. Okay, so plug them in the formula. X equals the opposite of B, which is 6, plus or minus the square root of negative 6 squared minus 4 times 1 times 3. Okay, all over 2 times 1. Okay, so x equals 6 plus or minus the square root of 36 minus 12. 4 times 1 times 3 is 12. Okay, all over 2. So I'm going to have x equals 6 plus or minus the square root of 24 all over 2. Okay, now here's the problem with 24. Square root of 24 has a perfect square factor in it. It's not a perfect square itself, but it does have a perfect square factor in it that we need to eliminate. So I'm going to simplify the square root of 24 up here, like we did in the previous topic, okay, in the previous lesson when we had to do that with some of the final problems in that one. Biggest perfect square factor of 24 is 4. So we're going to rewrite this as 4 times 6, split it, and rewrite it. Okay? So we're going to change the square root of 24 to 2 radical 6. So I get x equals 6 plus or minus 2 radical 6 over 2. Now, I need you to look at this for a second because this is going to get kind of tricky. If this number here, and this number here, and this number here all have a common factor that can be canceled out, we're going to do that to reduce the problem, reduce the roots even more. Okay, we want these in reduced form as much as possible. Okay, but it's only numbers on outside of radicals, and here is the trick. Okay, they all three have to have a common factor. Because remember, when we first set up the quadratic formula, this is really 2 fractions in one that we're working with here. So it's 6 over 2, and then 2 radical 6 over 2. So they both have to contain that common factor with the denominator. Okay, both parts on either side of the plus or minus sign. And they do. So we can divide each one of these by 2. There, there, and there. So I get a final answer of x equals 3 plus or minus the square root of 6. Because 2 divided by 2 becomes 1 there, 1 there, and 3 there. Okay? And those are the final answers. Okay? So that is about as complicated as it gets regarding reporting your final answers. You have to just check for that with the problems that you receive. And remember, follow the directions on Canvas. You want to make sure you put your answers in reduced radical form. We're not approximating these, okay? So make sure you put them in reduced radical form. I have to repeat it and do it again when I go to check. So make sure you follow directions, all right? One more problem to go here, and we are done. And just an extension from one we've already done. So this is going to be just one part. So I'm going to have you read it real fast. We're going to highlight our function again. It's the same one from the first video, right here. Okay. The only thing differently this time is we want to know at what times is the dolphin 14 feet above the water. So not like last time when it hits the water, 2 seconds. Okay. This time we want to know what times is it 14 feet above the water. So basically, when we solve this problem, y becomes what value? 14. Okay, so we're just going to create our equation. So we're going to have, it's y equals negative 16x squared plus 32x. We're going to place it with 14. So now I have 14 equals negative 16x squared plus 32x. Okay, and now I have to just solve this equation using the quadratic formula, because I will tell you, I'll give you a hint, this will not factor. So we're going to solve it using the quadratic formula on this one, and we will see what the final answers are. Okay, so I'm going to get the x squared term positive, so I'm going to actually move everything to the left side and get the right side equal to 0. Okay, so we'll do the same thing over here. So I get 16x squared minus 32x plus 14 equals 0. Okay? Now, we can make these numbers easier to work with because there is a GCF in this expression. There's a factor of 2 we can factor out. Okay? We can make this a lot easier for us. So we'll have 8x squared minus 16x plus 7 equals 0. And then I can put these numbers in the quadratic formula. Why don't you try that right now? I'm going to pause. You solve it from here, and then I'll catch up with you in just a moment. Okay, so here's what we're going to do. Okay, remember A is 8 this time, B is negative 16, and C is 7. Now, it would work if you didn't factor out the 2. It just makes your calculations a lot more complicated because you have larger numbers to work with. Okay, so if you don't want to factor out the 2, it's no harm, no foul. It's just going to make your numbers larger to work with. I like working with smaller numbers. So x equals the opposite of b, which is 16, plus or minus the square root, changed on me there, of negative 16 squared minus 4 times 8 times 7 all over 2 times 8. Okay? So I have x equals 16 plus or minus the square root. Now, negative 16 squared is positive 256. Okay? And 4 times 8 is 32. 32 times 7 is 224. Okay, so 256 minus 224 all over 16. Okay, So then reduce the radical, of course. X equals 16 plus or minus square root. And 256 minus 224, I believe, is 32. Okay. It's going to be over 16. Okay, now at this point, you could go ahead and continue to simplify it down if you want to. Okay, we're going to go ahead and practice that. So it'll give you a chance to practice with the radical again. So we'll do that over here on the side. So largest perfect square factor of 32 is 16. So it becomes 16 times 2. The square root of 16 times the square root of 2. 4 radical 2 is how you simplify radical 32. Okay? Put it on, replace it in the answer. So x equals 16 plus or minus 4 radical 2 over 16. This will give us a chance to, again, do the cancellation. There, and there. Okay, they all share a common factor of 4, so we're going to divide that out. Right there. Okay, there, and there. So when you divide 16 by 4, you get 4. When you divide 4 by 4, you get 1. So the final answer I'm going to get is x equals 4 plus or minus the square root of 2. Okay, all over 4. Now, we can approximate the square root of 2 to be, well, let's go ahead and let's do this. Let's put it up here on the calculator. Let me get out for a second and get my calculator up. And then we'll put the notes back up here next to it so we can split the screen. There we go. Okay, and let's just do square root of 2 real fast, see what the answer is. So 1.41, okay? Because I think it's around to the nearest hundredth. So we'll just put this information to good use. So the square root of 2 is 1.41. Okay, go back to notability all the way. Okay, so let me rewrite that a little bit so it's clear. 1.41. So our answers are going to be 4 plus 1.41 over 4. And then the other one's going to be 4 minus 1.41 over 4. Okay? So we're going to have answers that are 4 plus 1.41, so 5.41 over 4. And the other one, again, let me put the calculator up here. 4 minus 1.41, 2.59. Okay, and so now we're going to divide these. So 5.41 divided by 4, you get 1.3525 rounded off, so it becomes 1.35 seconds. Okay, and then 2.59 divided by 4 is about 0.65 seconds. So the dolphin is 14 feet in the air okay, at 0.65 seconds, and again at 1.35 seconds. Okay? So, this concludes this video, and you now can do your final lesson on this topic in the practice and prepare for your assessment. I will see you one more time for your final topic. Take care now, and don't forget to email me or send out a request for Hangout chat if you have any questions or need any additional help. All right? Take care, guys.